everyone, this is Anitta, Saji and Edwin Sebastian presenting the topic Electrochemical Machine. The word machining means removal of any substance and the word electrochemical resembles the mode of energy used. The two terms combined together give rise to a process known as electrochemical machining.
In this slide, we come across with what is electrochemical machining, its definition, parts, working principle, applications, advantages, and its disadvantages.
So, what is electrochemical machining or ECM? Electrochemical machining is a process of removing metal with the help of electrolysis process. The electrochemical process is also known as the reverse of the electroplating process because in electroplating, the metal is deposited on the surface of the workpiece, while in electrochemical machining, the metal is removed from the workpiece. This process is used for the large-scale production of machined parts. The history of electrochemical machining. The electrochemical machining is a modified yet different process which has its roots connected to electrolytic polishing, which was founded in the year 1911 by Russian chemist. It was in the year 1929 ECM was experimentally developed by W. Gessett, and it was in 1959 when an engineering company commercialized the use of electrolysis for the removal of metals. The ECM technology kept on becoming better with the passage of time past.
Chemical process. It is normally used for mass production and is used for machining extremely hard materials or materials that are difficult to machine using conventional methods. Its use is limited to electrically conductive material.
Next one is a principle of electrochemical machining. The major principle of electrochemical machining is based on the Faraday's law of electrolysis. Faraday's law of electrolysis states that when two electrodes, anode and cathode, are placed in an electrolyte, the mass of the metal deposited on the cathode coming from the anode is directly proportional to the potential difference applied across the electrodes.
Whenever the two electrodes, anode which is connected to positive terminal and cathode which is connected to negative terminal, is immersed in an electrolyte, such as NaCl. When the voltage is applied across the two electrodes, the material removal from the anode starts. The anode and cathode is placed very close to each other without touching. In ECM, the material removal takes place at atomic level, so it produces a mirror finish surface. ECM working is opposite to the electrochemical or galvanic coating.
Next one is the conceptual electrochemical model. In this model, NaCl is used as an electrolyte, the workpiece is placed as an anode, tool is used as a cathode, and a potential difference is applied. There is a very small gap between the workpiece and the tool for the removal of material. And as soon as a potential difference is applied between the anode and the cathode, the ions start moving from anode to cathode. The negative ions are attracted towards the workpiece, which is placed at the positive potential, and the positive ions are attracted towards the tool, which is placed at the negative potential. The chemical reaction take place in the basic process of electrochemical machining are as follows. Uh, the major reactions are NaCl gives Na plus Cl minus electron, and H2O splits into H plus OH minus ion. And the next reaction is a major reaction, that is a 2H plus 2 electron gives H2. Hydrogen ion gains electron and get converted into hydrogen gas.
So, the next one is the construction of electrochemical machining sector. The ECM system has the following modules. First one is power supply. So, the power supply is a source of energy that is provided to the setup. The power supply is generally a DC battery consisting of a potential difference from 3 to 30 volt depending upon their requirement.
Next one is electrolyte. An electrolyte is a salt solution in which the workpiece and tool are kept during the process of machining. It acts as a current carrying medium between the workpiece and the tool. It also helps in the removal of waste product from internal gaps and also acts as a coolant by preventing overheat of the tool and the workpiece.
The next thing is a tool. Tool or cathode used in ECM is one of the electrodes. It is also the desired shape in which the workpiece is to be cut. The tool used in ECM should always have accurate dimensions.
And the fourth one is the mechanical system. One of the most important element in the electrochemical machining is the mechanical system. It is used for the advancement of a tool that is perpendicular to the workpiece and is at a constant velocity.
The fifth one is tank. The tank contains the electrolyte, tool, and workpiece. All the reaction takes place here.
The next one is a pressure gauge. A pressure gauge is used to measure the pressure of electrolytes which is supplied to the tool.
Then the flow control valve. A flow control valve is used to control the flow of electrolyte which is supplied to the tool.
The eighth one is a pressure relief valve. In case the pressure of electrolyte flow exceeds a certain limit, the pressure relief valve opens and it sends the electrolyte back to that tank.
The next one is reservoir tank. The tank that stores pure electrolytes is called the reservoir tank.
The next one is the main part of this pump. There are two pumps used, namely A and B. Pump A is used to draw electrolytes from the reservoir tank, and pump B is used to supply the electrolyte to the reservoir tank.
Then the filter and the centrifuge. A filter is used to filter the electrolyte reaching the reservoir tank and prevents the accumulation of excess electrolytes. The function of a centrifuge is to separate the slug from the electrolyte.
Next one is the sludge container. A sludge container is used to store the sludge which is separated from the electrolyte. This sludge can be used for various experimental purposes. Next we will deal with the working of the electrochemical machining. The working of electrochemical machining starts with the advancement of tool towards the workpiece. The tool and the workpiece are kept in a suitable electrolyte with a very small gap between them. As soon as the potential difference is applied, that is DC current, the workpiece starts behaving as an anode and the tool starts behaving as a cathode. When the condition of electrolysis is fulfilled, the removal of metal from the workpiece starts. The removal takes place according to the shape of the tool. Material is removed from the workpiece and gets settled down in the form of sludge, which is due to the flow of electrolytes. The electrolyte then goes through a filtration process. In this filtration process, the electrolyte is passed through a centrifuge where the sludge is removed. Then it is passed through a filter where other remaining impurities are removed. If there is an increase in the pressure of an electrolyte, the pressure valve deviates the flow of electrolyte directly to the tank.
First, the workpiece is assembled in the fixture, and the tool is brought close to the workpiece. The tool and workpiece is immersed in a suitable electrolyte. After that, a potential difference is applied across the workpiece, which is anode, and tool, which is cathode. The removal of material starts. The material is removed in the same manner as we have discussed in the working principle. Tool feed system advances the tool towards the workpiece and always keeps a required gap in between them. The material from the workpiece comes out as positive ions and combine with the ions present in the electrolyte and precipitates as sludge. Hydrogen gas is liberated at the cathode during the machining process. Since the dissociation of the material from the workpiece takes place at atomic level, so it gives excellent surface finish. The sludge from the tank is taken out and separated from the electrolyte. The electrolyte after filtration again transported to the tank for the machining process.
The next one is the applications. The main applications of the ECM is grinding, steam turbine blades, drilling, profiling and contouring, and die sinking. ECM is used for heavy machining of hard materials which cannot be machined using conventional methods. Due to its high accuracy and surface finish, ECM is used for micro machining. As there is no contact between the tool and the workpiece, the final product obtained is accurate at the atomic level. ECM is also used for the production of very small gear systems which cannot be machined using typical machining process. ECM is used for machining turbine blades as it is difficult to machine due to its complex concave structure.
The major advantages of electrochemical machining are: electrochemical machining is suitable for hard materials. The electrochemical machining process is used for machining hard materials. Those materials which are difficult to machine using typical process are machined by using electrochemical machining. And the next one is negligible stresses. Unlike any other machining process, in electrochemical machining, there are no stresses produced as there is no contact between the tool and the workpiece. And the next advantage is no heat produced. There is negligible heat produced in this process of machining as there is no friction involved in the electrochemical machine. And the next advantage is no tool wear. As there is no friction involved and no heat produced in the electrochemical machining, the tool is not subjected to any stresses. And the major advantage is the surface finish. The surface finish obtained in the case of electrochemical machining is excellent. Mirror finished surfaces can be obtained by this process of electrochemical machining process. This is due to the removal of material at an atomic level. And the other advantage is the accurate dimension. Accuracy is very important in most industries. With the help of electrochemical machining, we can obtain accurate dimension because the electrochemical process involved in the electrochemical machining works on atomic levels. And the next one is a mass production. The electrochemical machining process is generally used for the mass production of the machine the parts. This is because various factors like electrolyte can be reused, no tool wear, no heat produced, etc.
The next one is the disadvantages of electrochemical machining. The first disadvantage is higher cost. The cost of electrochemical machining equipment is much higher when compared to other machining processes. The cost of maintenance is also high in the case of ECM. Corrosion. Generally, the parts which are machined using ECM are metals. We know that metals are electropositive and get corroded when they come in contact with a liquid. Hence, there is a chance that the metal workpiece may get corroded due to the electrolyte. The third disadvantage is large area. An ECM setup consists of various individual parts. Due to so many complex working parts, an ECM setup requires a large area. Hence, it is difficult to install the setup in a smaller area. The fourth disadvantage is limited materials. One of the major drawbacks of ECM is that only those materials which are good conductors of electricity can be machined. Semiconductors and bad conductors are not suitable for the machining process through ECM. The fifth disadvantage is it is hazardous to the environment. The reuse of electrolytes can be done for a limited cycle. After a certain time, there is a need to dispose of the electrolyte and sludge produced in the process. The waste products produced in the ECM process are harmful to dispose of. So,
These,
these are the references we have taken. Thank you.